This is lesson 9.7, E and natural logarithms. So the natural log of x is the logarithm of x to the base e, written ln x. For all x, ln x equals log base e of x. It sounds like a lot of gibberish. Few things you need to know. Basically, log base e of x right here, we write as ln x. So it's kind of like log base 3 of x, log base 2 of x, but we have this unique log called log base e of x. And basically, e to the natural log equals the natural log of e, and these all equal 1. And we'll use this to solve and simplify things. So a logarithm with base e, it's called a natural logarithm. I mean, it's ln, I think it's Latin or something. I don't know, but looks like it should be nl, but it's not. E is an irrational number, like pi. Irrational just means it can't be written as a fraction, so it goes on forever. It is about 2.718. So keep in mind, this means that on your calculator, if you do e to the first power, you'll get 2.718, and then a bunch of other numbers. So ln e, this is the same as log base e of e, and this equals 1, because if you think about it, e to the first power equals 1, if you rewrite it in exponential form. Natural log of 1 is 0, because if you think of this as log base e of 1, well, e to the 0 equals 1. Just going to kind of box around these. So natural log of e is 1, natural log of 1 is 0. Natural log of e to the x, well, this is just like log base e of e to the x. So we're looking at basically e to what power equals e to the x. So our answer is just x. If this is seeming confusing right now, don't worry yet. Natural log of 4, this is just calculator. So if you just put natural log of 4 in your calculator, you get 1.386. Like I said, if it's slightly confusing right now, don't worry about it yet. So here's how we actually do this. The fact that natural log is log base e, great. The way we use it, if we evaluate without using a calculator, if we look at this example 1 here, like let's start with A, e to the natural log is 1. We can just cancel this out. So e to the natural log of 5 is just 5. Looking at B, natural log of e is 1. They just cancel each other out. This is just 2. 2 natural log of e, well, natural log of e is 1. This is just 2. Natural log of 1 over e, let's rewrite this quick. Natural log of e to the negative first power. ln e cancel, so we get negative 1. Natural log of 1 is 0. So what you should memorize is the following. Natural log of e equals e to the natural log equals 1. Basically they cancel and you're left with whatever else was there. And natural log of 1 equals 0. That's what you want to memorize. So that's just evaluating or simplifying. Now we'll use our log rules. Since this is really just a different log, a specific log, log base e, we can use the log rules we learned prior. So natural log of 2 plus natural log of 3 minus natural log of 5. Do 2 at a time. Natural log of 2 plus natural log of 3 equals natural log of 2 times 3, and then we subtract natural log of 5. Well, natural log of 2 times 3 is natural log of 6 minus natural log of 5, and then we can combine these. It's the natural log of 6 over 5. For part B, again, we're trying to condense here, writing it as a single logarithm, so I'm going to move the 3 to the exponent and the 2 to the exponent. So we have natural log of 2 cubed minus natural log of 6 squared which is natural log of 8 minus natural log of 36, which is natural log of 8 divided by 36. And if we simplify that fraction, we get the natural log of 2 over 9. And that's our answer. And what is that? What are either of these answers in A and B? Only a calculator can tell you. I don't have a clue. All right, looking at the next one, part C. Natural log of A plus natural log of 5 plus natural log of C. When they're being added together, they're just multiplied in the same log. So natural log of A times 5 times C. Traditionally, we would write this as natural log of 5AC with the constant first, or the number, and then the variables in alphabetical order. This next one looks a little weird. I'm going to rewrite this as 1/3 natural log of 27 plus 1/2 natural log of 4 plus 1/2 natural log of 9. Then I'm going to move all these fractions up into the exponent position. So natural log of 27 to the 1/3 plus natural log of 4 to the 1/2 plus natural log of 9 to the 1/2. Well, 27 to the 1/3 power is 3, so we have natural log of 3. 4 to the 1/2 is 2. 9 to the 1/2 is 3. And then our final step is to multiply these together, so we have the natural log of 3 times 2 times 3. 3 times 2 is 6, times 3 is 18. So our answer is natural log of 18. Now we'll go the other way and we will expand the logs. So natural log of xyz to the 6th, multiplication turns to addition when we're expanding. So we have natural log of x plus natural log of y plus natural log of z to the 6th. The only thing we can deal with here is our exponent. So we can make this natural log of x plus natural log of y plus 6 natural log of z. Part B, same idea. Can turn this into natural log of a cubed plus natural log of square root of b. Natural log of a cubed, instead of square root of b, I'm going to write that as b to the 1/2, so we have an exponent. And then we'll move the exponents, just like we did before, like we do a lot of the time. So we get 3 natural log of a plus 1/2 natural log of b. For part C, now we have division. So division will turn into subtraction when we expand. Natural log of 2 to the 4th minus natural log of 5. If you wanted to, you could say, okay, 2 to the 4th is 16 and make that natural log of 16. That's just as correct as what I'm going to do, which is move the exponent out front and make this 4 natural log of 2 minus natural log of 5. Again, if you put natural log of 16 in your calculator, that's the same as 4 natural log of 2, so you're good either way. The next one, there's a couple different ways to do it. I'm going to do it this way. Let's say this is natural log of 3 squared. Just going to distribute that over 4 squared. And so we have division, which will be subtraction in terms of expanding. So we get natural log of 3 squared minus natural log of 4 squared. Could you make this 9 and 16? Sure, but I'm going to move the exponents. So I'm going to make this 2 natural log of 3 minus 2 natural log of 4. If you did it a different way, you might end up with 2 times in parentheses natural log of 3 minus natural log of 4. Or you could have natural log of 9 minus natural log of 16, all sorts of options. Calculator will give you the same thing either way. So now we're going to write each equation in the alternate form. So this was trickier when it was logs. Essentially what we're talking about here is ln form versus e form. That's really what this means. And when we had log base 3, for example, log base 2, log base 9, log base 10, whatever, you ended up writing it in exponential form and there was kind of more work involved. Maybe you wrote the triangle of power. For these, we'll just cancel out the natural logs and the e's. So for part A, to get rid of that e, I'm going to do an ln. Got to do it on both sides. Rules of math, rules of algebra. Ln e is just 1. So we end up with 3.91 equals the natural log of 50. Typically, we'll write it the other way of the natural logs first. Doesn't really matter, though. For part B, I see a natural log, so I'll put in an e to cancel out the natural log. We end up with e to the 1.39 equals 4. And how do I know what to do? I mean, basically, if I see a natural log, I'm going to cancel it out with an e. If I see an e, I'm going to cancel it out with a natural log. Part C, e to get rid of the natural log. And then we'll end up with 1/7 equals e to the negative 1.95. We'll probably put the e's first, but it doesn't really matter. Okay? Again, these are all true statements here, true mathematical statements. I see an e, so I'll do a natural log to it and do it to both sides. I end up with natural log of 1.45, that's this right side, equals 3/8. The last piece we have here is solving equations. Again, similar process as what we did with normal, sounds weird, normal, natural log, whatever, with logs of other bases than e, not natural logs. We would log both sides. Now typically we're going to do the natural log of both sides, or just cancel out the e or the natural log like we did above. If that confused you, ignore me, I'm just going to show you. All right, so e to the x equals 4. So what I want to do, I see an e, I'm going to do the natural log of both sides. Okay, and then natural log of e goes away. So we end up with x on the left equals natural log of 4, whatever that is. That's a calculator issue. That's our answer. For part B, the x is stuck in there with the natural log. So I'm going to e both sides. It's like exponentiate or something, but I'm going to e both sides. That's what I call it. E to the natural log goes away. So x equals e to the 6th. Part C, we have a 2x minus 1 kind of trapped in there. I'm going to get rid of the natural log. E to the natural log cancels. So 2x minus 1 equals e to the 1st. In your calculator, you would have to do e to the 1st. I'm just going to say e, kind of like you really never write x to the 1st, you just write x. Add 1 to both sides, 2x equals e plus 1. So to solve, you would divide by 2 on both sides. X equals e plus 1 divided by 2. Part D, you could e both sides, exponentiate both sides, but honestly, natural log of e is just 1. There's parentheses there, but still works. So they can just cancel. So we end up with 3 minus x equals 8. If you subtract 3 from both sides, negative x equals 5. Divide by negative 1. So x equals negative 5. For this next one, there's a couple ways to proceed. I'm just going to rewrite it first. Natural log of x. Natural log of 4 plus natural log of 7 can be rewritten as the natural log of 4 times 7. So we have natural log of x equals natural log of 28. The x is trapped in there with the natural log. Let's e it. Oh, look, both sides cancel. So x equals 28. Last one. Technically, we could move the 6 into the exponent here with the x if we wanted to. I'm going to divide by 6. That seems simpler. So natural log of x equals 24 over 6 is 4. We e both sides. E to the ln. They're gone. So x equals e to the 4th.